Okay. Oops. Guess I didn't change the title slide, but this is actually 2018 question 1 from CPC. Okay, so people are entering line for an escalator at this rate, where RT is people per second and T is seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 people per second. If there are 20 people in line at the time T equals 0, then I want to know how many people entered the line during the interval from 0 to 300.
That's integration. Integral from 0 to 300, the complicated function.
Okay, so it would look like that. I'm going to integrate from 0 to 300 of RT to T. That will tell me the change. There were 20 people in line. If I just want to know how many people entered the line, we don't need that 20. So, okay. Got a feeling it might be a better idea to throw this in. So I've got 270 people.
And people.
Okay. For part B, I want to know how many people are going to... Yep, how many people are in line at 300?
That's 20 plus integral from 20 plus answer from A.
Okay, we'll need one more thing.
Oh, and then minus 0.7 integral 0 to 300 0.7 dt.
Okay, so that's going to be 270 plus 20 minus 300 times 0.7. Is 80 total. What are our units?
People.
Okay. For part C, I want to know if there is a time when no people are in the escalator.
So that means RT should be 0.
Okay, so we'll have no people entering the line after t equals 300.
Yeah.
I want to know that when the total number of people will equal 0, not just RT.
So 20 plus integral from 0 to 300. That function.
Okay, we can call that RT.
Yeah, RT dt minus points integral from 0 to 300.
Okay, 0.7 dt.
Should be 0.
Once we hit 300, RT is 0, but we still have people leaving the line. We still have people leaving the line after the time 300.
Oh, so plus
RT is how many people are entering the line, but we still have people leaving the line after time equals 300.
But I thought we were finding the time, so we should write t instead of 300.
Okay, for this one as well, or just for this one?
Yeah, and that's equals 0.
Okay, only for the 0.7.
Yeah.
Okay. I think what I'm going to do is I'm going to break this up, because we already know how many people are there at 300. So I'm going to go to 300, but then we're going to subtract another 300 to t of 0.7. Okay, since all of this we already know from part B equals 80. This is really 80 minus 80 minus the rest of this.
Yeah.
Okay, so we're gonna leave.
Point 0.7 t minus 300 times 0.7. So if you calculate it, 1080 minus
Okay. So I divided everything by 0.7 and distributed our negative and then moved the t to the other side. So that gives us 80 divided by 0.7 plus 300 is 414.3.
Mm-hmm.
What are our units?
Seconds.
Okay. Then for part D, I want to know at what time is the number of people in line a minimum?
So we have to calculate ending point, 0 and 300, and derivative of RT dt. No, RT.
Okay, so I've got the end point 300 and then any times where we would get a minimum.
Mm-hmm.
When are we going to get a minimum?
When R prime t is 0.
R prime t would be the concavity of people. Would be the
Oh, when
concavity of
RT is
people
0.
entering the line. The acceleration of people entering the line.
When RT is 0.
Okay, not just RT. So RT is only the people entering. We still have people exiting.
Oh. RT minus 0.7.
There we go. S equals 0. So whenever RT equals 0.7, we'll have a time.
Mm-hmm.
Okay, so in the calculator, we're going to calculate those intersects. Going from 0 to 300. Yeah, it's going to be a little bit difficult to see, so I'm going to redraw this. That's a little better. Okay, our first term here at 166.574. So I'm just going to write, that's their second t, so 166.574. 719. Okay, then our first intersect here at 33.013298.
Mm-hmm.
Okay, yep. While I go back for my calculator, what's T0 and what's T300?
T0 is 44.
T0 is not 44.
Oh wait, it's 0.
Nope.
No. T0?
When T is 0, how many people are online?
Negative 0.7.
Nope. I can't have negative 0.7 people in line.
Oh, that's integral. No, 20 people.
20 people. And at 300? Do you remember?
80.
80. Okay, so then we've got our two intersects here. I'm going to plug those into our total people equation, which we had earlier, as this equation, but I'm going to need to change that 300 to our t. People in line at any time is 20 plus the integral from 0 to t of rt minus the integral from 0 to t of 0.7 dt. And we'll plug in t1 and t2. Okay, this is 20 plus the integral of y1 minus 0.7 in terms of x from 0 to a. So there were an expected 3.8 people in line. And then if we do the same thing, but change A to B, that's our second intersect we calculated. We've got 158 about people in line. Okay, so to the nearest whole number, how many people are in line at the minimum?
T equals T1.
At t equals t1, which is around 33 seconds. How many people to the nearest whole number?
What? Oh, 167.
Nope.
No, 33.
Nope.
No. 3.8 people.
To the nearest whole number, find the number of people in line
4?
at this time. Okay. All right. Any questions on anything we did?
No. How about the school?
They're doing health inspections right now as we speak. Assuming those go well, I'm sure Ms. Martinez will tell you when they open.
And okay.
For right now, if they go well, then the teachers will come back on Monday and the students will come back after that. Grades 8 through 12 are coming back first. Then they're coming back in sections.
I thought only seniors and 8th grader coming first.
I saw 8 through 12.
Oh. Mm-hmm.
I'm sure you get the details if we pass the health inspection today, though.
Okay.
Just Ms. Martinez can't release them until we actually have the go-ahead from the local government to say we can open.
Mm-hmm.
Okay, so I will see you tomorrow for physics, and then we are off school for Labor Day on Friday.
Yep.
Thanks a lot. I'll see you tomorrow.
Bye bye.
Goodbye.